Entirely new forms of lightning have been discovered, up to 1,000 times bigger than any bolt previously seen. While normal lightning fires down below clouds, these giant bolts shoot up 80 kilometers into space.
It was sort of as if the biologist suddenly discovered a new human body part. We just didn't know it was there.
This lightning, 6 times more powerful than passenger planes are designed to withstand, may be the real killer in a spate of baffling air disasters. And for the first time, we can reveal the photograph that sparked a secret NASA inquiry. Was this the proof that a high-altitude lightning strike caused the crash of the space shuttle Columbia? Each day, the Earth is shaken by 8 million bolts of the sky's most powerful force, lightning. Energy from one bolt explodes in a split second, but could power a household for half a year. At any moment, 1,800 storms pummel our planet. Each one is a giant battery. Inside a storm, water turns to hail. Falling ice crashes on rising droplets, creating static electricity. Charges of up to 100 million volts build up. Arcs of electricity fire out. More than 90% of all bolts fire within clouds. But a highly charged storm will fire a cascade of electricity down to Earth, drawn to the highest point. A blade of grass can trigger lightning, or even a person. Each year, 1,000 people around the world die after direct hits. A lightning bolt is only 3 centimeters wide, but at 33,000 degrees Celsius, it is hotter than the surface of the sun. This heat expands the surrounding air, which explodes outwards as thunder. The sound of lightning. A lightning flash travels at the speed of light. Its thunder travels much more slowly. The shorter the time between the flash and the thunder, the closer the lightning bolt. Few cloud-to-ground strikes are longer than 3 kilometers, and textbooks always used to say no lightning could exist above the clouds. But then weatherman Walt Lyons aimed his camera across the Colorado Plains on July the 6th, 1993. What he saw overturned 200 years of scientific certainty in an instant. He filmed these video images showing lightning 80 kilometers high and 40 kilometers wide, firing above the clouds. Their existence had been dismissed as fantasy. Now their discovery sheds new light on what has been causing airplanes to fall from the sky. The discovery of Megalightning began with ordinary people seeing extraordinary things. In 1969, Stuart Beecher was defending a mortar pit outside Saigon in South Vietnam when a storm broke.
There was this giant flash of lightning that reached from the ground through the base of the cloud, completely illuminated the cloud, and out the top in this absolutely beautiful double helix that seemed to just go on forever. It went like it was just like it was going straight into space, and it was one of those, hey, look at that! And of course it's gone.
There had even been photographs. This was taken at Mount Isa in Australia in 1968. Scientists had ignored the sightings. Skeet Vaughan, a senior NASA engineer, met a witness who had seen giant lightning in 1981. As a trained pilot, Vaughan took the sighting seriously.
And I wrote an article in a magazine and asked pilots to tell me if they'd seen any unusual lightning or anything out of the ordinary. And then a number of pilots, about 19 of them, sent me letters telling me about this kind of thing.
Pilot Larry Partridge was one of those who wrote to Vaughan, revealing that he'd seen giant lightning above the clouds, going up and not down.
And all of a sudden, pow, just a split second, this huge bolt of lightning came out of the top and disappeared into the deep blue space. The captain turned to me just then, wide-eyed, and said, "Did you see that?" And I said, "Yes." So we turned and told the flight engineer. He said, "That's impossible. Lightning doesn't go up."
A strike of lightning appeared to come out of the top of the cloud, went straight and bright white for maybe 10 or 15,000 feet, and then broke up into a lot of fingers that went through the different colors of the spectrum and disappeared off into space.
But most of the pilots said they had never talked to many people about this, because they were somewhat reluctant, because they were afraid, since they were flying at night and things of this sort, that they might think they were having hallucinations or other problems, and they didn't want to talk about it. Nobody would believe them anyway, until you have documented evidence, a photograph or something like that.
The pilots would have to wait until solid proof turned up to show they weren't hallucinating. The problem was, few people get to see above storms, and the pilots who do rarely carry cameras. But if the observer is below clear skies and there's a distant storm, what's above thunderclouds can be seen from the ground. By chance, in 1989, University of Minnesota physicist Franz Winkler was testing a camera in these very conditions. He was filming the sky above a storm 200 kilometers away. Ordinary lightning was flashing below the horizon. But when Professor Winkler played back the tape, he saw something different. The camera had recorded a flash above the cloud tops, showing twin pillars of light. But this was where lightning was not supposed to exist. At 10 times the size of Mount Everest, the mystery flash dwarfed any bolt ever recorded. The possibility of giant lightning came at a bad time for the American Space Agency, NASA. On March the 26th, 1987, they launched a $100 million military satellite into storm clouds. What happened next would make NASA face the sky's most powerful force. A $100 million rocket had lifted into orbit from Cape Canaveral in 1987. NASA engineers had defied the weather and launched into a storm. A camera tracked the rocket until it disappeared into clouds. When it panned back down to the launch pad, lightning struck. This is the bolt that passed through the rocket, striking the launch pad.
We have lost telemetry. We don't know quite why yet. No telemetry data from any source at Hangar AE.
With onboard computers burnt out by lightning, the vehicle was veering off course. Mission Control remotely detonated the rocket before it could crash into populated areas. Asked if they had considered the dangers of lightning, NASA were caught off guard.
If lightning hit a rocket as it was going up, would something like that happen? What would it do? Would it knock out the electrical system or what?
Well, there could be any number of things would happen. I think at this point I don't want to really speculate.
NASA were criticized for ignoring the dangers of lightning.
When the rocket goes up into a cloud, there are very strong electric fields. So the rocket itself is quite long, metallic, and a conductor, but in addition, there's a plume of ions below it that extends the equivalent length to 2 or 3 times the length of the rocket. So you, in essence, have a very long wire, and in the strong field of perhaps 10, 20, 30,000 volts per meter over 400 meters, you can generate something of the equivalent of 1 million volts. So you get a discharge then through the rocket, the plume, and that triggers the lightning. Well, in the worst case, it could actually potentially blow the rocket up.
When a mystery flash was filmed in 1989, NASA had reason to fear a new form of lightning that could blow up a rocket high above the clouds. NASA asked Skeet Vaughn to find evidence that the phenomenon was real. He searched for similar flashes in NASA's archive of storms filmed from Earth's orbit.
When we were back looking through the tapes, we were able to go through probably 17 or 20 hours of tapes. And in those tapes, you have to go through each video frame, and then you have to identify the video frame and what on that tape, and then try to compare it with what you know should be out there.
By 1992, the detective work had turned up startling images. They showed the edge of the Earth. Bright columns fired upwards 70 kilometers from the clouds, towering over the horizon.
We found a total of probably 19 of those things on different shuttle flights over time.
NASA feared they might be more dangerous than the ordinary lightning that had previously hit their rocket. A race began to find out if these were giant bolts and if they could bring down the space shuttle. NASA turned to Walt Lyons, a world expert in the detection of distant lightning strikes. NASA had used his skills to make launches safer after the 1987 disaster. Their rocket safety team now shared their concerns over the new discovery.
When it appeared that there was this whole new form of lightning not coming down but going up, naturally the safety people were concerned, and they said, we better find out about this.
Walt Lyons' observatory on Yucca Ridge was perfect for hunting lightning. Colorado's clear skies offered views above storms over 1,000 kilometers away in Tornado Alley, the prairie states, hit by the worst of the 20 million lightning bolts that strike the United States each year. NASA gave Lyons the job to film above storms to see if the mystery flashes might be a threat. He ordered a remote camera to set up on top of his observatory.
This very camera here came on the day of 6 July 1993. We took it out of the box, and that very evening, there was a massive thunderstorm going on out in Kansas, about 300 kilometers away, and it was just lighting up the whole sky, and I said, aha, this looks good. So I just sat and waited.
Lyons linked the camera back to the video recorder in his viewing room.
11 o'clock, and it was really fun to watch the lightning, on this video enhancement image, and looking at it, and that's impressive, that's nice. $12 o'clock, yeah, that's nice. 1 o'clock, it's nice, but not much was happening.
Lyons was weary from monitoring the storm when he suddenly saw flashes that did not behave like ordinary lightning.
Then bing! I saw something on the screen. I said, what was that? About a minute later, another bing. And I said, oh boy. By the time the sun came up around 4:30, we had seen 250 of these bings. We just picked the right night with the big storm in the perfect location, and it was classic beginner's luck.
In one night, Walt Lyons had proved the phenomenon was real, but it still had no name.
A friend of us suggested calling them sprites, which shows up in several Shakespeare's plays. And I said, that's a beautiful name, it's perfect, because it's sort of a fleeting, ephemeral type of creature, and it doesn't imply something about the physics.
A year after Walt Lyons' discovery, a University of Alaska team set out to photograph the sprites from the air, up close and in color. Student Matt Hevner volunteered for the mission.
They basically needed somebody to operate the cameras and hit record on the VCRs and figure out, where to fly, things like that.
The flights took place on the night of America's 4th of July celebrations.
In terms of dangers that may be associated with the sprites, since we were going to be in airplanes flying around the storms, was there any danger to us? And in general, the pilots were even more worried about that than we were. So we trusted their judgment to keep us far enough from the storms that we weren't in danger.
As the fireworks exploded below, Matt Hevner's camera captured what no one had seen before. The sprites were colored a vivid blood red.
There were a few storms where we were seeing sprites maybe 3 or 4 times a minute, and so that was pretty exciting.
In one night, the lightning hunters had bagged hundreds of images that had revealed the true color of sprites. They were red and blue neon-type glows, a sign they might be explosions of electricity, exciting gases in the high atmosphere. From the ground observatory at Colorado, Walt Lyons filmed another peculiarity. The sprites appeared to be dancing across the cloud tops. But were they just a trick of the light? Ordinary lightning gave warning of its power with the sound of thunder. If sprites made a similar sound, it would prove them to be more than a mirage.
Sprite is very impulsive. Boom, like that. Which means a lot of air is potentially being heated or pushed around. So I wondered, could there be some analogy to thunder produced by a sprite?
Dr. Alfred Bedard, who would hunt for sprite thunder, had been a guardian of world security during the Cold War.
If the communist bloc does attack, our radar sites and observers will sound the alert.
Dr. Bedard's audio array near Boulder, Colorado, can hear the frequencies undetectable by human ears called infrasound. Until the advent of satellites, his system was the main warning of rogue atom bomb tests. He can detect sound from the other side of the world. If he could measure infrasound from sprites, it would show they had enough power to fire out on the same spectrum as an atom bomb.
We detected sounds from sprites. These were detected at here in Boulder.
Dr. Bedard can hear the subaudible sound of the sprite by playing it back through a program in his computer.
There's a very loud, vicious sounding rumbling, and all of this is subaudible again, but when you play it back at high speeds, you wouldn't want to get near something like that.
No communist atom bomb had escaped Dr. Bedard's infrasonic array. Now red sprites might be tracked far away, even those that flashed during daylight hours. The sprites could be heard. They needed to be examined in greater detail. Professor Umran Inan, a leading physicist at Stanford University, would unleash his students to peer inside their fiery hearts.
I encouraged then one of our students, Elizabeth Kirk, and I said, Elizabeth, why don't we do telescopic measurements of this? What we saw in the first few images, some sprites at least, were consisting of just a whole lot of hundreds of filaments forming the body of the sprite.
Inan's telescope helped prove that a sprite, which at first was thought to shoot up, actually fires downwards. They're not a single bolt, but a multitude of interlaced lightning channels. The picture was being completed. To see giant lightning, time must be stopped. This is because sprites happen even faster than the blink of an eye. Sprites are generated in the electric field above a storm. The first thing seen is a flat disk called a halo. It appears at a height of 85 kilometers. The field must be strong enough for the halo to grow into a sprite. Electricity flows down to make a red balloon of energy the size of a mountain range. As the charge flows down, denser air squeezes the current into 30-meter-wide filaments. The sprite showers 100 square kilometers of these blue lightning shards onto cloud tops and then disappears. But what pulls vast currents from space to make huge towers of electrical energy? Could some monstrous force conjure sprites from below the clouds? And could this in turn help explain some of the most mysterious air disasters since the dawn of the jet age? The glamorous advertising for the new jets had helped foster the myth that lightning could not hit a plane in flight.
The jet age is now here. Flying will be above the weather.
But jets were not immune to weather. Lightning was striking planes often.
About each 1,500 hours of flight, which is about 1 or 2 lightning flash per aircraft and per year. So it's not a rare event, so it's a very common event.
Planes are not usually harmed by lightning. Although strikes reach 100 million volts, they last only milliseconds. The metal skin of a jet plane allows the electricity to pass through harmlessly, leaving only superficial damage. But here was a deadly conundrum. Lightning strikes have killed 483 people in 5 major plane crashes in 30 years. The disaster that ended the myth that jets were safe from lightning happened in 1963. A recording exists of the moment.
Station 3 of a plane crash, 859. Respond your ambulances to a plane crash at the Lansing Road, just east of Elkton, 906.
The emergency services tape records the aftermath of Pan American Flight 214. On descent to Philadelphia in 1963, the plane flew into a storm, then crashed into a cornfield, killing all 81 people aboard. The official inquiry blamed a fuel tank explosion, but said a massive lightning strike had blown off part of a wing and burnt through rivets. If planes were safe from lightning, what had brought down Flight 214? Weathermen would have to throw away their textbooks to solve the mystery.
If you go back and look at the textbooks from 20, 30 years ago, most people thought lightning was a giant spark that lowered negative charge from the cloud down to the ground.
Scientists had known since 1773 that lightning was electricity. It was found to come in 2 types that either repel or attract, negative or positive. Well into the 1970s, weathermen knew of only one type of lightning: negative charged bolts.
With the advent of lightning detection networks and other systems to look at really what's going on inside the lightning discharge, we found out that a number of them sort of worked in reverse. They lowered positive charge to ground, and these became known as positive lightning. We didn't realize there were such major differences. They don't just strike, over, say, 10 milliseconds. They strike, and then they just burn away for hundreds and hundreds of milliseconds, which is an eternity when you're being lit up by 50,000 kiloamps.
Positive lightning could explain the Elkton enigma.
The Elkton crash was during winter, and there isn't that much lightning in the northeastern United States during winter, but when there is, it tends to be positive. There is a fair amount of lightning in intense snowstorms, and our experience has shown that that's often positive and very powerful.
Flight 214 had been engulfed by the type of storm bristling with positive lightning. A positive bolt would unleash many times the current and burn far longer than ordinary lightning. A strike by positive lightning could explain the fate of Flight 214. But until a plane crash investigator saw his friend blasted from the sky, the true power of this new form of positive lightning would remain a mystery. In 1993, the world of weathermen had been rocked by the discovery of a giant form of lightning above the clouds. They'd only recently found another breed of superbolts below the clouds called positive lightning. The role of positive lightning in air accidents would never have won official recognition if plane crash investigator Peter Claydon hadn't seen his friend struck by lightning. The drama began at the London Gliding Club.
That day looked reasonable. It started off a little bit of low cloud, and then it cleared to a nice blue sunny April day, and it was a nice day for flying.
We took the glider out of the hangar here. We then towed it over to the launch point.
I wasn't aware Peter was flying because there were a lot of people flying that day.
I didn't take any particular notice of the dark cloud.
That whole section of sky was black, evil-looking black, and it was slowly encroaching upon the airfield.
And that's when things went wrong.
Well, I'd landed and taxied in and was keeping an eye on the sky, as pilots generally do. And suddenly there was this very bright streak of light diagonally across the sky.
The force of the explosion had burst both of my eardrums.
I was aware of what was obviously a glider, descending nose down, rotating as it did so.
I do remember all my clothes fluttering wildly. I remember pulling the ripcord, and I then remember being surrounded with, like autumn leaves, all the little bits of glider that were all fluttering to the ground.
Peter Claydon realised that if his plane had been hit, he would have been killed. He'd not been wearing a parachute.
Had I been struck by lightning, then almost certainly I wouldn't be standing here now.
The crash was a mystery. Gliders had been struck before and survived. Peter Claydon wanted to know why this bolt was so devastating.
I thought this might actually be a very good opportunity to look at the subject of lightning. And we discussed ways in which we may be able to quantify the level of energy in the strike by test work at their laboratories.
The laboratory could simulate ordinary lightning, but the damage to this glider was very much out of the ordinary.
This actually came from the glider which was struck. It hasn't actually melted. What you can see is simply the magnetic forces which have crushed the pipe down, and it is indicative of the fact that it was a very severe strike which took this glider.
To simulate the lightning strike, we actually use an impulse generator which can generate over 1 million volts.
The lab found their machines were too weak to replicate the immense force that destroyed the glider. Their finding had ominous implications.
Putting all the figures together, it was concluded by everybody who worked on this that it could have been as much as 6 times the present level to which aircraft are designed to tolerate with minimal damage. 6 times.
Though it looks like a normal bolt, this positive lightning can burn 10 times as long and unleash 6 times the power of ordinary negative strikes. The killer lightning travelled with an even bigger accomplice.
We were able to take pictures of sprites above storms while we were able to map the lightning going on inside of the storm. We've never been able to do this before. Went back and got the raw lightning data, and for every sprite, there was a positive lightning.
Positive lightning and sprites were one continuous force that stretched from the edge of space to where ordinary planes fly. Regulators had set airline safety thresholds for lightning before the discovery of sprites. The world's airlines fly with shielding to withstand only 1/6 of the awesome power inflicted by the positive lightning fired below the sprites.
We're learning there's a whole subclass of extremely energetic positive cloud-to-ground lightning that lowers maybe 10 times more current to ground than the old textbook said you should get.
There was potential salvation.
We're able now to actually use the sprite as sort of like the coal miner's canary. Because when you see a sprite up there, that means there is an exceptionally unusual lightning discharge in the cloud below.
The sprites themselves might be used as neon signs warning of the positive lightning below. Positive lightning was deadly, and the sprites above struck an area 1,000 times bigger. Could they hit rockets? NASA funded the first sprite hunt in 1993 to find out.
So NASA was worried that many of the spacecraft, like the shuttle, weren't designed to take lightning discharges, and so if the shuttle was flying through sprites, what would the possible effect be on the shuttle or any other spacecraft?
In 1996, Walt Lyons reported to NASA on the dangers of sprites. He concluded that their vast size spread out their energy, making them unlikely killers, but cautioned not enough was known to be certain they were harmless.
We concluded that the space shuttle probably was not endangered by a Sprite. I'm not sure I'd volunteer to be the first astronaut to fly through one either. We just didn't know for sure. It works out that if you had about 100 descents into Kennedy, on landing, over the Midwestern U.S., during summer nighttime periods, you'd have about one chance in that 100 of being involved in the envelope of a Sprite.
3, 2, 1, and liftoff.
NASA took their chances on the 107th shuttle mission in January 2003. No extra shielding from the new forms of lightning had been installed, but the shuttle was to hunt for the giant bolts, alongside 200 other science experiments. The Sprite hunt had been inspired by Yoav Yer, Israel's leading lightning researcher.
I came up with the idea of maybe doing some Sprite research from space during the night part of the orbit. There were earlier tries to try and look for Sprites from space. We had a superior instrument on board, so we figured out we can do a really good job in hunting those elusive Sprites.
Yoav's friend, Israel's first astronaut, Ilan Ramon, was to film lightning from the shuttle.
This phenomena was new for the scientists, and they are trying to figure out what it is all about. And our camera is actually the best way to monitor and try to catch these Sprites going up to space.
The shuttle crew pursued giant lightning during 42 night orbits.
This is Mission Control Houston, pilot Willie McCool operating the MEDEX experiment, with one of its secondary observations being to look for the Sprites, or the lightning phenomena that are associated with the thunderclouds and the lower ionosphere, or uppermost atmosphere of the Earth.
The crew filmed hours of video of giant storms like this. They followed lightning illuminating the clouds from below to pinpoint the area where Sprites would explode above the clouds at the edge of space.
And Houston, we're back tracking good storms again.
Video of the first storms was beamed back to Mission Control. The final tapes were kept on board to be handed directly to Yoav Yer. But the handover from the most ambitious hunt yet for giant lightning was never to happen. At the end of its 16-day mission, the space shuttle Columbia was re-entering the Earth's atmosphere above the coast of California. On board were the films of storms from space that could help scientists understand giant lightning.
On the morning of February 1st, we were expecting the re-entry of the shuttle, watching the big screens and just chatting away.
A crew member filmed the last moments inside the cockpit. Superheated air can be seen flickering across the porthole as it re-enters the atmosphere at 27,000 miles an hour. Cameras inside Mission Control at Houston recorded the last communications.
Everything looked good to you? Control and rates and everything is nominal, right?
The shuttle videotape cuts off abruptly. Radio messages are answered only by static. Mission Control was unaware that cameramen outside were already filming what was left of the shuttle hurtling to the ground.
Columbia, Houston, UHF comm check.
It went away, so I do believe it's instrumentation.
Okay. GC flight. GC flight. Fly GC. Lock the doors.
And we got all this terrible sinking feeling, and people started crying. I started crying. I couldn't hold myself, and it was really, really hard. Really, really hard.
Searchers fanned out across Louisiana and Texas to gather wreckage. All the astronauts sent to hunt giant lightning were killed. Immediately there was fear that they'd been brought down by the phenomenon they'd been sent to record.
Well, as part of my work now at Los Alamos, I operate a ground-based array of lightning detectors. And it was rather early in the morning, and I got a call from Maury Pongratz, one of my supervisors at the lab, and he said, "Have you seen the news yet?" And I said, "No." And he said, "Well, save all your data, because the shuttle's just disappeared."
When we heard that the breakup began around the West Coast, we went and checked the weather there, and, you know, certainly sprites jump into your mind.
A further shock for the lightning hunters came from San Francisco. Another cameraman had photographed the descent of the shuttle.
And then it came out that there was this photo associating it with lightning.
When he first learned of the crash, amateur astronomer Dr. Peter Goldie was already concerned by an anomaly on one of his pictures of the space shuttle's re-entry.
When I saw the picture and heard the television in the background suggesting that things were amiss, the hair on the back of my neck stood up.
The picture that shocked Goldie showed the bright line made as the Columbia streaked by in the 8 seconds of his time-lapse photo. The re-entry trail was joined by a purple corkscrew of light.
I didn't know what it was, but by all appearance, it appeared to be a lightning bolt.
The apparent bolt struck 2 seconds before a sudden brighter glow signaled that the craft was breaking into pieces. 6 minutes later, the shuttle exploded. When a newspaper got wind of the photo, the killing potential of Megalightning was front-page news. The paper had seen the photo, but was forbidden from publishing it. NASA had sent an agent to collect the image and the camera.
The initial evidence from that photo that possibly sprites were responsible for the disaster was kind of a shock in that way, that, you know, these had been sort of benign, friendly things to study, and now they might have serious implications.
The lightning hunters turned detective to find out if a sprite was the killer.
There was a photograph, and there was some concern that the shuttle during re-entry, of course, did go through the altitudes that sprites and other high-altitude electrical phenomena occur. To cover all bases, NASA was interested in making sure that any possible evidence of electrical effects is thoroughly considered.
But the last recordings of Columbia's hunt for giant lightning had been lost in the crash. Rescuers combed through debris. It took 2 weeks to find the tapes. They were airlifted to Israel, where the lightning hunters were coping with the death of Ilan Ramon, their countryman sent to photograph the bolts.
This science work, that it's the heritage of the crew for us. Each time we meet, we have these little talks and conversations about memories from the mission, like personal stuff. So far, we've only looked at one hour, and we've found at least 15 confirmed events, what we call images that we are sure are either sprites or some of which we don't know what we saw.
Among the first images made public from Columbia's lightning hunt was a meteor re-entry, apparently sparking a bolt of giant lightning.
On the night of January 22nd, notice first meteor coming, second one will come from. We see lightning below, this is the horizon, and this is the sprite.
Was it possible that the shuttle had acted like a meteor, its re-entry trail turning Columbia into a lightning rod, attracting a giant bolt? NASA's sub-panel considered this horrific possibility in secret. Meanwhile, the public was being told wing damage and mismanagement had caused the accident.
The first cause was the foam that came off and hit the reinforced carbon-carbon. The second was the loss within NASA of its system of checks and balances.
NASA's probe into the shuttle lightning strike was never made public. The reason, fear had turned to embarrassment, then relief. Experts who checked the San Francisco photo concluded the image of lightning was probably caused by camera wobble.
Our conclusion was that there was no evidence for any electrical activity at the altitudes that the shuttle went through and the region of the Earth that it went through. There was a camera shot that it turned out to most likely be an artifact of the particular camera.
The giant lightning was dismissed as a ghost in the machine. But the man who'd been America's lookout for rogue atomic tests had heard something very real in the re-entry path of the doomed space shuttle. A secret NASA probe had studied a photo apparently showing lightning hitting the space shuttle Columbia seconds before it broke up. While it was concluding that no lightning had struck, new evidence emerged. America's expert in the detection of distant atom bomb tests, Dr. Alfred Bedard, had been the first to confirm Sprite thunder. His infrasonic array was listening when the shuttle went down.
My wife and I were watching television and we were looking at the reentry, and all of a sudden it became evident that things were not normal, and then it became evident that it was a true tragedy. So at that point we knew we had detected reentries in the past, and we looked at our data to make sure we had something, and it looked like we did.
The detectors had heard a sinister sound before the shuttle's breakup.
I'm going to start this playing. So this is an hour of data in the real time. This has been compressed in time to 9 seconds, so we're actually able to hear the infrasound. I call it infra audio as a compressed audio track. So what you're hearing are the bursts of energy early. Right in through here. And then that hollow thud.
The signal showed there'd been an energy burst outside the shuttle before it disintegrated, like the sound of a distant gunshot. This was evidence other forces were in play.
It had the characteristics of a geophysical kind of an event of some sort. And as I said, at this range, in the past, we've had signals quite similar that were associated with fairly good-sized earthquakes.
The bomb detectors had measured a hugely powerful event, the force of an earthquake high in the sky. Its epicenter was estimated to be in the flight path of the doomed shuttle.
Best guess would be it would be right in somewhere around in here. Perhaps San Francisco, perhaps a little bit south of there.
Dr. Bedard had heard something like an earthquake crossed with the sound of a sprite. What could it be?
The chances are the sprite per se is not going to be a threat to the space shuttle, but there are other creatures up there which we maybe shouldn't be so sure about.
Could Columbia have triggered an unknown weather phenomenon from the force that unleashed the earthquake-sized rumble? When NASA's Alaskan researchers flew a special color camera above storms in 1994, they were stunned to find a more aggressive type of bolt no one had ever seen before.
The jet storm was just amazing. It was a storm over Arkansas, and first of all, the storm was almost continuously illuminated. There was so much lightning going on down below. And then the jets were shooting off maybe once every 10 seconds at their peak. And so you would just see these spouts of light and all this lightning going on down below. And that was amazing. That was unlike any storm I've seen before.
Even from 150 kilometers away, the blue jet, highlighted here, can be seen bursting up from the cloud tops. It erupts 15 kilometers upwards, 5 times the reach of an average lightning bolt. Apart from the Alaskan footage, little is known about their power and where they strike.
I remember the first time I saw the videotape, I was just absolutely stunned. I couldn't believe what I was seeing, because that really wasn't predicted by anybody. That was a total shock.
A bigger shock was to come. Just months before the shuttle crash, a series of blue jets were filmed that dwarfed any recorded before. First, lightning hunters in Puerto Rico called this film potentially the most powerful type of lightning yet recorded. Then off Taiwan's coast, researchers filmed these towering bolts erupting 80 kilometers into space from the top of a distant storm.
They got this enormous column of light coming up from the cloud top all the way to the ionosphere. They could see it with their naked eye. It was a screaming brilliant blue. This seems to be far more than the blue jets we saw back in 1994. This may well be an entirely new phenomena, or just sort of an incredibly energetic form of the old blue jet. We still don't quite know what it is for sure.
Only 5 gigantic jets have been captured on film. Their killing potential remains unknown.
It's a whole menagerie out there. It's a zoo. There could be other types of discharges and emissions in the upper atmosphere.
The lightning hunters are back where they were when the first images confirmed Megalightning was no fairy tale.
In terms of the middle atmosphere, I think there still are unknowns and new discoveries to be made. It definitely should be studied in terms of safety for both manned and unmanned space flights.
It's just a lot of things happening above the cloud tops that we never knew 10 years ago and perhaps have not yet designed properly for.
The higher we fly into the realms of Megalightning, the more certain we are to encounter beasts that have yet to be discovered.